Question 71. Your company is running a stateless application on a compute engine instance. The application is used heavily during regular business hours and lightly outside of business hours. Users are reporting that the application is slow during peak hours. You need to optimize the application's performance. What should you do? A. Create a snapshot of the existing disk. Create an instance template from the snapshot. Create an autoscaled managed instance group from the instance template. B. Create a snapshot of the existing disk. Create a custom image from the snapshot. Create an autoscaled managed instance group from the custom image. C. Create a custom image from the existing disk. Create an instance template from the custom image. Create an autoscaled managed instance group from the instance template. Most voted. D. Create an instance template from the existing disk. Create a custom image from the instance template. Create an autoscaled managed instance group from the custom image. The best approach to optimize the application's performance is: A. Create a snapshot of the existing disk. Create an instance template from the snapshot. Create an autoscaled managed instance group from the instance template. Key considerations. 1. Application scaling. Autoscaling allows your application to scale dynamically based on the load, ensuring optimal performance during peak hours and cost savings during off hours. 2. Stateless architecture. Since the application is stateless, you can easily replicate the application in multiple instances, which can distribute the load and improve performance during high traffic periods. 3. Snapshot for backup. Creating a snapshot provides a backup of the existing disk, ensuring that you can recover the application setup if needed. 4. Instance template. An instance template defines the configuration of instances in the managed instance group, ensuring consistent configuration across all instances. Explanation. 1. Snapshot. Creating a snapshot of the existing disk captures the current state of the application, which is useful for creating a new instance template. 2. Instance template. From the snapshot, you create an instance template, which can then be used to configure the autoscaled managed instance group. This ensures that all instances in the group are identical and run the same application version. 3. Autoscaling. The managed instance group with autoscaling ensures that as demand increases, more instances are created automatically to handle the load. Conversely, during off hours, fewer instances are running, optimizing cost and resource usage. Analysis of other options. B. Create a snapshot of the existing disk. Create a custom image from the snapshot. Create an autoscaled managed instance group from the custom image. This option is less efficient because a custom image is typically used for creating a custom operating system setup, while an instance template derived from the snapshot is more appropriate for scaling. C. Create a custom image from the existing disk. Create an instance template from the custom image. Create an autoscaled managed instance group from the instance template. Creating a custom image from the disk is unnecessary since the snapshot can serve as the base for the instance template. This extra step could complicate the process without providing additional benefits. D. Create an instance template from the existing disk. Create a custom image from the instance template. Create an autoscaled managed instance group from the custom image. This approach unnecessarily involves creating a custom image after creating the instance template, adding an extra step that doesn't contribute to performance optimization. Conclusion. A is the best approach because it simplifies the process by using a snapshot to create an instance template and autoscaling, which optimizes performance by scaling the application based on demand while ensuring consistent configuration across instances. Question 72. Your web application has several VM instances running within a VPC. You want to restrict communications between instances to only the paths and ports you authorize, but you don't want to rely on static IP addresses or subnets because the app can autoscale. How should you restrict communications? A. Use separate VPCs to restrict traffic. B. Use firewall rules based on network tags attached to the compute instances. C. Use Cloud DNS and only allow connections from authorized host names. D. Use service accounts and configure the web application to authorize particular service accounts to have access. The best approach to restrict communications between instances in your web application, without relying on static IP addresses or subnets, is B. Use firewall rules based on network tags attached to the compute instances. Explanation. Firewall rules based on network tags provide a flexible and scalable solution to control traffic between instances in your VPC. Network tags. Tags are applied to instances to group them by roles or functionality. These tags can then be used in firewall rules to control access between the instances. Since your app is autoscaling, using network tags allows new instances to automatically inherit the correct access controls based on their tags, without having to rely on static IP addresses or subnets. This approach is dynamic and can adapt to the changing number of instances in an autoscaling environment. Analysis of other options. A. Use separate VPCs to restrict traffic. Using separate VPCs might isolate the traffic, but it introduces unnecessary complexity. Inter-VPC communication would require VPC peering or VPNs, which is not ideal when you want to restrict communication between instances dynamically within the same VPC. C. Use Cloud DNS and only allow connections from authorized host names. Cloud DNS is a service for translating domain names into IP addresses but does not directly control or restrict network traffic between instances in a VPC. Restricting access based on DNS or host names is less effective for controlling internal VPC traffic in a way that is scalable and dynamic. D. Use service accounts and configure the web application to authorize particular service accounts to have access. Service accounts are useful for managing access at the application level, example, granting permissions for accessing Google Cloud services, but they are not designed to restrict network traffic between VMs within a VPC. Service accounts manage identity and permissions, not network communication controls. Conclusion. B is the best choice as it provides the necessary flexibility and scalability to manage access control in an autoscaling environment using dynamic firewall rules based on network tags. Question 73. You are using Cloud SQL as the database backend for a large CRM deployment. You want to scale as usage increases and ensure that you don't run out of storage, maintain 75% CPU usage course, and keep replication lag below 60 seconds. What are the correct steps to meet your requirements? A1. Enable automatic storage increase for the instance. 2. Create a stack driver alert when CPU usage exceeds 75% and change the instance type to reduce CPU usage. 3. Create a stack driver alert for replication lag and shard the database to reduce replication time. Most voted. B1. Enable automatic storage increase for the instance. 2. Change the instance type to a 32-core machine type to keep CPU usage below 75%. 3. Create a stack driver alert for replication lag, and deploy memcache to reduce load on the master. C1. Create a stack driver alert when storage exceeds 75%, and increase the available storage on the instance to create more space. 2. Deploy memcache to reduce CPU load. 3. Change the instance type to a 32-core machine type to reduce replication lag. D1. Create a stack driver alert when storage exceeds 75% and increase the available storage on the instance to create more space. 2. Deploy memcache to reduce CPU load. 3. Create a stack driver alert for replication lag and change the instance type to a 32-core machine type to reduce replication lag. The best approach to meet the scaling and performance requirements for your Cloud SQL-based CRM deployment is B1. Enable automatic storage increase for the instance. 2. Change the instance type to a 32-core machine type to keep CPU usage below 75%. 3. Create a stack driver alert for replication lag, and deploy memcache to reduce load on the master. Explanation. 1. Enable automatic storage increase. This ensures that storage increases automatically as usage grows, avoiding the risk of running out of storage. 2. Change the instance type to a 32-core machine. Adjusting the instance type with more cores helps maintain CPU usage below the desired 75% by providing more resources to handle increasing load. 3. Create a stack driver alert for replication lag and deploy memcache. Memcache helps reduce the load on the master database by caching frequently accessed data, which can help reduce replication lag and improve overall performance. Stack driver alerts help monitor replication lag and notify you when thresholds are breached, enabling proactive management. Analysis of other options. A. Enable automatic storage increase for the instance. Create a stack driver alert when CPU usage exceeds 75% and change the instance type to reduce CPU usage. Create a stack driver alert for replication lag and shard the database to reduce replication time. Sharding the database introduces significant complexity and is not always required unless the database is under extreme load. It can also complicate queries and maintenance. The other steps are sound, but sharding is often more complex than needed for this use case. C. Create a stack driver alert when storage exceeds 75% and increase the available storage on the instance to create more space. Deploy memcache to reduce CPU load. Change the instance type to a 32-core machine type to reduce replication lag. Increasing storage when it exceeds 75% and deploying memcache to reduce CPU load are valid approaches. However, focusing on reducing replication lag only with instance type changes without considering the optimization of the master database load, using memcache, would not be as effective. D. Create a stack driver alert when storage exceeds 75% and increase the available storage on the instance to create more space. Deploy memcache to reduce CPU load. Create a stack driver alert for replication lag and change the instance type to a 32-core machine type to reduce replication lag. This option combines effective actions for scaling storage and CPU performance but lacks the direct action of proactively reducing the load on the master database through caching, as in option B. Conclusion. B is the best choice as it focuses on automatic scaling, proactive monitoring, and efficient load reduction using caching, which aligns with the business goals of maintaining optimal CPU usage, minimizing replication lag, and ensuring sufficient storage capacity. Question 74. You are tasked with building an online analytical processing, OLAP, marketing analytics and reporting tool. This requires a relational database that can operate on hundreds of terabits of data. What is the Google recommended tool for such applications? A. Cloud Spanner, because it is globally distributed. B. Cloud SQL, because it is a fully managed relational database. C. Cloud Firestore, because it offers real-time synchronization across devices. D. BigQuery, because it is designed for large-scale processing of tabular data. The best approach to building an online analytical processing, OLAP, marketing analytics and reporting tool is D. BigQuery, because it is designed for large-scale processing of tabular data. Explanation. 1. BigQuery is designed for OLAP workloads. It is optimized for handling massive datasets, including hundreds of terabits of data. BigQuery is a fully managed, serverless, highly scalable, and cost-effective data warehouse solution that is ideal for performing complex analytical queries on large datasets. 2. Designed for analytical workloads, unlike transactional databases, OLAP systems focus on analyzing large volumes of historical data. BigQuery's architecture is optimized for fast querying and can handle large-scale analytical workloads efficiently. Analysis of other options. 1A Cloud Spanner, because it is globally distributed. While Cloud Spanner is a highly scalable and globally distributed database, it is better suited for transactional workloads, OLTP, rather than OLAP use cases. Cloud Spanner is designed for high availability, strong consistency, and horizontally scalable transactions, but it is not specifically optimized for analytical processing at the scale of OLAP. 2B Cloud SQL, because it is a fully managed relational database, Cloud SQL is suitable for small to medium-sized relational databases, but it is not designed to handle the scale, hundreds of terabits, required for OLAP workloads. It might struggle with performance when queried for large analytical tasks compared to BigQuery. 3C Cloud Firestore, because it offers real-time synchronization across devices. Cloud Firestore is a NoSQL database designed for real-time data syncing and is not suitable for OLAP workloads. It is optimized for applications requiring low latency, real-time updates, but it is not designed for large-scale analytics. Conclusion: D is the best choice because BigQuery is specifically built for large-scale data analysis and is the recommended tool by Google for OLAP applications, especially when dealing with hundreds of terabits of data. Question 75. You have deployed an application to Google Kubernetes Engine, GKE, and are using the Cloud SQL proxy container to make the Cloud SQL database available to the services running on Kubernetes. You are notified that the application is reporting database connection issues. Your company policies require a post-mortem. What should you do? A. Use Cloud SQL instances restart. B. Validate that the service account used by the Cloud SQL proxy container still has the Cloud Build Editor role. C. In the GCP console, navigate to Stackdriver logging. Consult logs for GKE and Cloud SQL. D. In the GCP console, navigate to Cloud SQL. Restore the latest backup. Use kubectl to restart all pods. The best approach to resolving the database connection issues in your Google Kubernetes Engine, GKE, deployment and performing a postmortem is: C. In the GCP console, navigate to Stackdriver logging. Consult logs for GKE and Cloud SQL. Explanation: 1. Consulting logs provides insights into the issue. Stackdriver logging, now part of Google Cloud's operations suite, will allow you to examine logs from both GKE and Cloud SQL. Logs can give valuable details about what happened, such as database connection attempts, errors, or configuration issues. It helps in diagnosing the root cause of the issue, which is essential for postmortem analysis. 2. Correlating GKE and Cloud SQL logs, since the issue might be related to either the application in GKE or the database itself. Reviewing logs from both services will provide a comprehensive view of the incident. Analysis of other options. 1A. Use Cloud SQL instances restart. Restarting the Cloud SQL instance may temporarily resolve connectivity issues, but it does not address the root cause. This step would be more of a workaround rather than a postmortem analysis. 2B. Validate that the service account used by the Cloud SQL proxy container still has the Cloud Build Editor role. This action is not directly related to the database connection issue. The Cloud Build Editor role is typically not necessary for the Cloud SQL proxy container to work. The more important validation would be ensuring that the service account has the correct Cloud SQL client role. 3D. In the GCP console, navigate to Cloud SQL. Restore the latest backup. Use kubectl to restart all pods. Restoring a backup should only be considered if data corruption is suspected, which is unlikely the cause of simple connection issues. Additionally, restarting all pods does not provide any insight into the underlying problem and should not be done without identifying the actual issue. Conclusion: C is the best approach because it focuses on identifying the root cause by reviewing relevant logs. This provides the necessary information for both resolving the issue and conducting a proper postmortem. Question 76. Your company pushes batches of sensitive transaction data from its application server VMs to Cloud PubSub for processing and storage. What is the Google recommended way for your application to authenticate to the required Google Cloud services? A. Ensure that VM service accounts are granted the appropriate Cloud PubSub IAM roles. B. Ensure that VM service accounts do not have access to Cloud PubSub, and use VM access scopes to grant the appropriate Cloud PubSub IAM roles. C. Generate an OAuth to access token for accessing Cloud PubSub, encrypt it, and store it in cloud storage for access from each VM. D. Create a gateway to Cloud PubSub using a cloud function, and grant the cloud function service account the appropriate Cloud PubSub IAM roles. The best approach to authenticate your application to the required Google Cloud services is: A. Ensure that VM service accounts are granted the appropriate Cloud PubSub IAM roles. Explanation. 1. Granting appropriate IAM roles to the VM service account. By assigning the necessary Cloud PubSub IAM roles to the VM service account, you ensure that the VMs can authenticate directly and interact with Cloud PubSub. This is a simple, secure, and Google-recommended way to manage authentication. It avoids the need for managing additional tokens or credentials manually. 2. Service accounts for authentication. Service accounts are the standard mechanism for authenticating applications running on Google Cloud services, providing a secure and scalable way to authenticate VM instances without hard-coding sensitive information like tokens. Analysis of other options. 1b. Ensure that VM service accounts do not have access to Cloud PubSub, and use VM access scopes to grant the appropriate Cloud PubSub IAM roles. This approach is incorrect because VM access scopes are outdated and not recommended for controlling access to Google Cloud services. IAM roles attached to the service account are the preferred method. 2c. Generate an OAuth to access token for accessing Cloud PubSub, encrypt it, and store it in cloud storage for access from each VM. This approach involves unnecessary complexity and security risks. Storing sensitive tokens in cloud storage and handling them manually is error-prone and not recommended. 3d. Create a gateway to Cloud PubSub using a cloud function, and grant the cloud function service account the appropriate Cloud PubSub IAM roles. This adds an unnecessary layer of complexity by introducing an additional cloud function to act as a gateway. Direct authentication through the VM service account is simpler and more efficient. Conclusion. A is the best choice because it follows Google's recommended best practices for secure and efficient authentication using service accounts with appropriate IAM roles. This ensures the application can securely authenticate to Cloud PubSub without the need for additional steps or complexity. Question 77. You want to establish a compute engine application in a single VPC across two regions. The application must communicate over VPN to an on-premises network. How should you deploy the VPN? A. Use VPC network peering between the VPC and the on-premises network. B. Expose the VPC to the on-premises network using IAM and VPC sharing. C. Create a global cloud VPN gateway with VPN tunnels from each region to the on-premises peer gateway. D. Deploy cloud VPN gateway in each region. Ensure that each region has at least one VPN tunnel to the on-premises peer gateway. The best approach to deploy the VPN for your compute engine application across two regions with communication to an on-premises network is: D. Deploy cloud VPN gateway in each region. Ensure that each region has at least one VPN tunnel to the on-premises peer gateway. Explanation. 1. Deploying cloud VPN in each region. By deploying a cloud VPN gateway in each region, you ensure redundancy and optimal performance for the communication between the VPC and the on-premises network. Each region has its own VPN tunnel to the on-premises peer gateway, providing a high availability and fault-tolerant solution. 2. Handling regional deployment. Since the application spans multiple regions, deploying VPN in both regions guarantees continuous connectivity even if one region experiences issues, ensuring consistent communication to the on-premises network. Analysis of other options. 1a. Use VPC network peering between the VPC and the on-premises network. VPC network peering is typically used to connect VPCs within Google Cloud, not to connect a VPC to an on-premises network. Therefore, it is not suitable for this scenario where you need to connect to an on-premises network. 2b. Expose the VPC to the on-premises network using IAM and VPC sharing. IAM and VPC sharing are used for sharing VPCs across different projects within Google Cloud, not for connecting to on-premises networks. This approach doesn't fulfill the requirement of establishing a VPN connection to an on-premises network. 3c. Create a global cloud VPN gateway with VPN tunnels from each region to the on-premises peer gateway. While a global VPN gateway can be used for some use cases, this does not leverage the full potential of multi-region deployment. Each region should have its own gateway to ensure localized, efficient communication. Conclusion. D is the best choice because it ensures that each region has dedicated VPN tunnels to the on-premises network, offering redundancy and high availability. This approach is the most scalable and fault-tolerant solution for the given requirements. Question 78. Your applications will be writing their logs to BigQuery for analysis. Each application should have its own table. Any logs older than 45 days should be removed. You want to optimize storage and follow Google recommended practices. What should you do? A. Configure the expiration time for your tables at 45 days. B. Make the tables time partitioned and configure the partition expiration at 45 days. C. Rely on BigQuery's default behavior to prune application logs older than 45 days. D. Create a script that uses the BigQuery command line tool, BQ, to remove records older than 45 days. The best approach to optimize storage and follow Google recommended practices for managing logs in BigQuery is B. Make the tables time partitioned and configure the partition expiration at 45 days. Explanation. 1. Time partition tables. Time partitioning in BigQuery allows you to divide your table into segments based on a date or timestamp field. This helps in organizing large datasets efficiently. Each application will have its own table, and the data can be partitioned based on the date field. 2. Partition expiration. By configuring the partition expiration to 45 days, any data older than 45 days will automatically be deleted, saving on storage costs and ensuring that logs are efficiently managed. This is a native BigQuery feature that automates the cleanup process, ensuring that you don't need to manually manage or script the deletion of old data. Analysis of other options. 1a. Configure the expiration time for your tables at 45 days. While this may seem like a good option, configuring expiration on the entire table rather than on individual partitions is not ideal for this use case. Expiring the entire table could cause all the logs to be removed, regardless of when they were written, and may not align well with the need to keep recent logs. 2c. Rely on BigQuery's default behavior to prune application logs older than 45 days. BigQuery does not automatically prune logs older than a specific age unless partition expiration is configured. The default behavior does not handle data retention based on age, which is why a more explicit approach, like partition expiration, is needed. 3d. Create a script that uses the BigQuery command line tool, BQ, to remove records older than 45 days. This would require manual intervention and periodic execution of the script, leading to operational overhead. While it is a possible approach, it does not leverage BigQuery's native capabilities for automated data retention. Conclusion. B is the best option because it optimizes storage costs by using time-based partitioning and automates the removal of old logs after 45 days, following Google recommended best practices for managing time series data in BigQuery. Question 79. You want your Google Kubernetes Engine cluster to automatically add or remove nodes based on CPU load. What should you do? A. Configure a horizontal pod autoscaler with a target CPU usage. Enable the cluster autoscaler from the GCP console. Most voted. B. Configure a horizontal pod autoscaler with a target CPU usage. Enable autoscaling on the managed instance group for the cluster using the gcloud command. C. Create a deployment and set the max unavailable and max surge properties. Enable the cluster autoscaler using the gcloud command. D. Create a deployment and set the max unavailable and max surge properties. Enable autoscaling on the cluster managed instance group from the GCP console. The best approach to automatically add or remove nodes in a Google Kubernetes Engine (GK) cluster based on CPU load is: B. Configure a horizontal pod autoscaler with a target CPU usage. Enable autoscaling on the managed instance group for the cluster using the gcloud command. Explanation. 1. Horizontal pod autoscaler HPA. The HPA automatically scales the number of pods in a deployment or replica set based on observed CPU usage or other metrics, but CPU is a common one. Configuring an HPA with a target CPU usage ensures that your application can scale based on the load. 2. Cluster autoscaler. The cluster autoscaler is a GK feature that automatically adjusts the number of nodes in the cluster based on the pod resource requirements. Enabling this feature ensures that your cluster will add nodes when there is insufficient CPU or memory to schedule new pods and will remove nodes when they are underutilized. Using the gcloud command to enable autoscaling on the managed instance group allows you to manage the scaling behavior programmatically and is an efficient way to automate this task. Analysis of other options. 1a. Configure a horizontal pod autoscaler with a target CPU usage. Enable the cluster autoscaler from the GCP console. While this option is almost correct, enabling the cluster autoscaler from the GCP console is a manual process. The gcloud command is a more efficient, automated way to achieve this. 2c. Create a deployment and set the max unavailable and max surge properties. Enable the cluster autoscaler using the gcloud command. Setting max unavailable and max surge pertains to deployment strategies for rolling updates, not node scaling. This option does not address CPU-based node scaling. 3d. Create a deployment and set the max unavailable and max surge properties. Enable autoscaling on the cluster managed instance group from the GCP console. Similar to option A, this involves enabling autoscaling manually from the console, which is less automated and can be managed more efficiently through the gcloud command. Conclusion. B is the best choice because it combines the use of both horizontal pod autoscaler for pod scaling and cluster autoscaler for node scaling, all managed in an automated, command-line fashion using the gcloud command. Question 80. You need to develop procedures to verify resilience of disaster recovery for remote recovery using GCP. Your production environment is hosted on-premises. You need to establish a secure, redundant connection between your on-premises network and the GCP network. What should you do? A. Verify that dedicated interconnect can replicate files to GCP. Verify that direct peering can establish a secure connection between your networks if dedicated interconnect fails. B. Verify that dedicated interconnect can replicate files to GCP. Verify that Cloud VPN can establish a secure connection between your networks if dedicated interconnect fails. C. Verify that the transfer appliance can replicate files to GCP. Verify that direct peering can establish a secure connection between your networks if the transfer appliance fails. D. Verify that the transfer appliance can replicate files to GCP. Verify that Cloud VPN can establish a secure connection between your networks if the transfer appliance fails. The best solution is B. Verify that dedicated interconnect can replicate files to GCP. Verify that Cloud VPN can establish a secure connection between your networks if dedicated interconnect fails. Why is option B the best choice? 1. Dedicated interconnect for high-performance primary connectivity. Dedicated interconnect provides a high-throughput, low-latency connection between your on-premises network and GCP, suitable for transferring large amounts of data during disaster recovery scenarios. It is the preferred method for establishing a secure and high-performing primary connection to GCP. 2. Cloud VPN as a redundant backup. Cloud VPN serves as a secure, encrypted, and cost-effective backup connection. If dedicated interconnect fails, Cloud VPN can ensure continuous connectivity between your on-premises network and GCP. This approach offers reliability and resilience, essential for disaster recovery. 3. Alignment with GCP best practices. Using dedicated interconnect as the primary connection and Cloud VPN for redundancy is a well-documented disaster recovery strategy in Google Cloud. It ensures both high performance and secure failover. Why not the other options? Option reason it's not ideal. A direct peering is not designed for disaster recovery use cases. It lacks the same level of encryption and flexibility as Cloud VPN for backup purposes. C. The transfer appliance is a physical device used for one-time data migrations, not for establishing continuous connections for disaster recovery. Direct peering does not offer sufficient backup flexibility. D. The transfer appliance is not relevant for disaster recovery, as it is designed for initial bulk data transfer. Cloud VPN as a backup connection is appropriate but does not align with using the transfer appliance for this purpose. Conclusion. Option B provides the most robust, secure, and scalable solution for disaster recovery. Dedicated interconnect offers the necessary high-performance connection for regular operations, while Cloud VPN ensures secure and redundant failover. This approach aligns with GCP best practices for establishing resilient disaster recovery procedures. Question 81. Your company operates nationally and plans to use GCP for multiple batch workloads, including some that are not time-critical. You also need to use GCP services that are HIPAA certified and manage service costs. How should you design to meet Google best practices? A. Provision preemptible VMs to reduce cost. Discontinue use of all GCP services and APIs that are not HIPAA compliant. B. Provision preemptible VMs to reduce cost. Disable and then discontinue use of all GCP services and APIs that are not HIPAA compliant. C. Provision standard VMs in the same region to reduce cost. Discontinue use of all GCP services and APIs that are not HIPAA compliant. D. Provision standard VMs to the same region to reduce cost. Disable and then discontinue use of all GCP services and APIs that are not HIPAA compliant. The best solution is B. Provision preemptible VMs to reduce cost. Disable and then discontinue use of all GCP services and APIs that are not HIPAA compliant. Why is option B the best choice? 1. Cost management with preemptible VMs. Preemptible VMs are significantly more cost-effective compared to standard VMs, making them ideal for batch workloads that are not time-critical. This aligns with the company's goal to manage service costs effectively. 2. Ensuring HIPAA compliance. Disabling and discontinuing non-HIPAA compliant services is critical for maintaining compliance with HIPAA regulations. Disabling the APIs first ensures that there are no accidental invocations, which helps prevent compliance violations during the transition period. 3. Alignment with Google best practices. Google's recommended approach for regulated environments includes using preemptible VMs for cost savings and ensuring that only HIPAA-compliant services are active in the project. Why not the other options? Option reason it's not ideal. A. While preemptible VMs are cost-effective, simply discontinuing non-compliant services without disabling their APIs first risks accidental usage during the transition. This approach lacks a safeguard. C. Standard VMs are more expensive and do not align with the cost-saving goals for non-time-critical batch workloads. Additionally, discontinuing non-compliant services without a phased approach could lead to compliance gaps. D. Similar to option C, using standard VMs increases costs unnecessarily. Disabling APIs is a good step, but this option does not leverage preemptible VMs for cost management. Conclusion. Option B provides a balanced approach to managing costs and maintaining HIPAA compliance. Preemptible VMs address the need for cost efficiency, while disabling and discontinuing non-compliant services ensures regulatory adherence. This approach aligns with Google Cloud best practices and ensures a secure, compliant, and cost-effective environment. Question 82. Your customer wants to do resilience testing of their authentication layer. This consists of a regional managed instance group serving a public REST API that reads from and writes to a Cloud SQL instance. What should you do? A. Engage with a security company to run web scrapers that look for users' authentication data on malicious websites and notify you if any is found. B. Deploy intrusion detection software to your virtual machines to detect and log unauthorized access. C. Schedule a disaster simulation exercise during which you can shut off all VMs in a zone to see how your application behaves. D. Configure a read replica for your Cloud SQL instance in a different zone than the master, and then manually trigger a failover while monitoring KPIs for our REST API. The best solution is D. Configure a read replica for your Cloud SQL instance in a different zone than the master, and then manually trigger a failover while monitoring KPIs for your REST API. Why is option D the best choice? 1. Testing resilience with failover simulation. Configuring a read replica in a different zone ensures high availability for the database layer. By manually triggering a failover, you can evaluate how the system handles zone failures and ensure the application remains functional during disasters. 2. Monitoring KPIs. Tracking key performance indicators, KPIs, during the failover provides valuable insights into the system's behavior and user impact. This enables the team to identify bottlenecks and ensure the authentication layer can withstand disruptions. 3. Alignment with best practices. Google Cloud recommends having replicas in different zones for resilience. Testing failover scenarios proactively ensures your architecture is fault-tolerant and meets operational requirements. Why not the other options? Option reason it's not ideal. Running web scrapers to detect leaked authentication data does not address resilience testing. It focuses on security breaches rather than the infrastructure's ability to handle failures. B. Deploying intrusion detection software improves security but does not test the resilience of the authentication layer or help in simulating and evaluating disaster recovery scenarios. C. Shutting down all VMs in a zone without a controlled failover plan risks data unavailability and is not a structured approach to testing resilience for the database or the application. Conclusion. Option D is the most effective choice as it directly tests the resilience of the authentication layer by simulating failover scenarios for the Cloud SQL instance. It ensures that the regional managed instance group and the REST API can handle database disruptions while monitoring system performance. This approach aligns with Google Cloud best practices for disaster recovery and resilience testing. Question 83. Your BigQuery project has several users. For audit purposes, you need to see how many queries each user ran in the last month. What should you do? A. Connect Google Data Studio to BigQuery. Create a dimension for the users and a metric for the amount of queries per user. B. In the BigQuery interface, execute a query on the jobs table to get the required information. C. Use BQShow to list all jobs. Per job, use BQLS to list job information and get the required information. D. Use Cloud Audit Logging to view Cloud Audit logs, and create a filter on the query operation to get the required information. The best solution is B. In the BigQuery interface, execute a query on the jobs table to get the required information. Why is option B the best choice? 1. Direct access to job metadata. The information_schema.jobs_by_user view in BigQuery provides detailed metadata about queries executed by users, including the number of queries, execution times, and users who ran them. This makes it a straightforward and efficient way to audit user activity. 2. Ease of use. Running a query in the BigQuery interface is user-friendly and does not require additional tools or setup, such as connecting to external services or navigating complex logs. 3. Alignment with Google best practices. Using BigQuery's built-in information_schema tables for auditing ensures high accuracy and leverages the native capabilities of the platform. Why not the other options? Option reason it's not ideal. A. While Google Data Studio can visualize query data, setting it up requires additional configuration and is not as direct or efficient as querying the jobs table. It also does not inherently provide detailed query execution metadata. C. Using BQShow and BQLS involves manual steps to retrieve job data, which is time-consuming and less efficient than directly querying the jobs table. It also does not provide a straightforward way to aggregate data by user. D. Cloud Audit logs can track query operations, but filtering and analyzing logs is more complex and less tailored for this specific purpose compared to the jobs table in BigQuery. Conclusion. Option B is the most efficient and accurate method for auditing query activity in BigQuery. It uses native features like the information_schema.jobs_by_user view to directly access user-specific query data, ensuring a streamlined and effective process that aligns with Google Cloud best practices. Question 84. You want to automate the creation of a managed instance group. The VMs have many OS package dependencies. You want to minimize the startup time for new VMs in the instance group. What should you do? A. Use Terraform to create the managed instance group and a startup script to install the OS package dependencies. B. Create a custom VM image with all OS package dependencies. Use Deployment Manager to create the managed instance group with the VM image. C. Use Puppet to create the managed instance group and install the OS package dependencies. D. Use Deployment Manager to create the managed instance group and Ansible to install the OS package dependencies. The best solution is B. Create a custom VM image with all OS package dependencies. Use Deployment Manager to create the managed instance group with the VM image. Why is option B the best choice? 1. Minimizing startup time. Creating a custom VM image with all necessary OS package dependencies pre-installed ensures that when new VMs are launched, they start with all required software already in place. This eliminates the need for long startup scripts to install packages after boot, thus minimizing startup time. 2. Automation with Deployment Manager. Using Deployment Manager to automate the creation of the managed instance group simplifies the process and ensures consistency across all instances. It allows for easy configuration and scaling while leveraging the custom VM image for efficient provisioning. 3. Google Cloud Best Practices. Google recommends using custom images for VMs when dealing with specific dependencies or configurations to improve provisioning speed and reliability. This approach adheres to Google Cloud best practices for performance and automation. Why not the other options? Option reason it's not ideal. A. While using Terraform to automate infrastructure is a good practice, relying on startup scripts to install OS packages can significantly increase VM startup time, especially if many packages need to be installed. C. Puppet is a configuration management tool, but using it to install OS packages after VM startup introduces additional complexity and delays, increasing startup time and reducing automation efficiency. D. Using Ansible for post-boot configuration in conjunction with Deployment Manager adds unnecessary complexity and delays the startup process by installing dependencies after the VM is up, rather than having them pre-configured in a custom image. Conclusion. Option B is the most efficient approach as it leverages a custom VM image with all necessary dependencies pre-installed, ensuring fast VM startup times and smooth automation. By using Deployment Manager in conjunction with custom images, the process is streamlined and adheres to Google Cloud's best practices for managing instance groups. Question 85. Your company captures all web traffic data in Google Analytics 360 and stores it in BigQuery. Each country has its own dataset. Each dataset has multiple tables. You want analysts from each country to be able to see and query only the data for their respective countries. How should you configure the access rights? A. Create a group per country. Add analysts to their respective country groups. Create a single group, all_analysts, and add all country groups as members. Grant the all_analysts group the IAM role of BigQuery job user. Share the appropriate dataset with view access with each respective analyst country group. B. Create a group per country. Add analysts to their respective country groups. Create a single group, all_analysts, and add all country groups as members. Grant the all_analysts group the IAM role of BigQuery job user. Share the appropriate tables with view access with each respective analyst country group. C. Create a group per country. Add analysts to their respective country groups. Create a single group, all_analysts, and add all country groups as members. Grant the all_analysts group the IAM role of BigQuery data viewer. Share the appropriate dataset with view access with each respective analyst country group. D. Create a group per country. Add analysts to their respective country groups. Create a single group, all_analysts, and add all country groups as members. Grant the all_analysts group the IAM role of BigQuery data viewer. Share the appropriate table with view access with each respective analyst country group. The best solution is A. Create a group per country. Add analysts to their respective country groups. Create a single group, all_analysts, and add all country groups as members. Grant the all_analysts group the IAM role of BigQuery job user. Share the appropriate dataset with view access with each respective analyst country group. Why is option A the best choice? 1. Access control at dataset level. Sharing datasets provides a more manageable approach to granting access compared to sharing individual tables. In BigQuery, datasets logically group tables, and sharing the entire dataset ensures that analysts have access to all the tables within that dataset. This minimizes the complexity of managing individual table-level access and ensures that any new tables added to the dataset in the future are automatically accessible to analysts from that country. 2. IAM role for query execution. Granting the BigQuery job user role to the all_analysts group allows the users to execute queries against BigQuery. This role is appropriate for analysts who need to run queries, as it grants permission to initiate queries, but not to modify or manage the datasets. 3. Country-specific access. Creating separate country groups and assigning analysts to the relevant groups ensures clear segmentation of access. By sharing the appropriate dataset with the respective country group, you can ensure that only the analysts from each country have access to their specific data. Why not the other options? Option reason it's not ideal. B. Sharing individual tables introduces unnecessary complexity when managing permissions, especially as the number of tables grows. Managing access to datasets provides a more scalable and streamlined approach. C. Sharing datasets ensures analysts have access to all data within the dataset, but sharing individual tables may lead to potential issues with table access management over time. Additionally, the BigQuery data viewer role would only provide read access without the ability to run queries, which may not meet the needs of analysts who need to execute queries. D. While sharing individual tables could be an option in very specific scenarios, it complicates the management of access as datasets grow and new tables are added. Moreover, it might require more administrative overhead in the long run. Conclusion. Option A is the most appropriate choice because it ensures that analysts only access the data relevant to their country while simplifying the management of permissions by using datasets instead of individual tables. It strikes the right balance between security, scalability, and ease of administration, making it the best solution for controlling access to BigQuery data in this scenario. Question 86. You have been engaged by your client to lead the migration of their application infrastructure to GCP. One of their current problems is that the on-premises high-performance SAN is requiring frequent and expensive upgrades to keep up with the variety of workloads that are identified as follows: 20 terabits of log archives retained for legal reasons, 500 gigabytes of VM boot data volumes and templates, 500 gigabytes of image thumbnails, 200 gigabytes of customer session state data that allows customers to restart sessions even if offline for several days. Which of the following best reflects your recommendations for a cost-effective storage allocation? A. Local SSD for customer session state data. Lifecycle managed cloud storage for log archives, thumbnails, and VM boot data volumes. B. Memcache backed by Cloud Data Store for the customer session state data. Lifecycle managed cloud storage for log archives, thumbnails, and VM boot data volumes. C. Memcache backed by Cloud SQL for customer session state data. Assorted local SSD backed instances for VM boot data volumes. Cloud storage for log archives and thumbnails. D. Memcache backed by persistent disk SSD storage for customer session state data. Assorted local SSD backed instances for VM boot data volumes. Cloud storage for log archives and thumbnails. Let's reassess the options and take a closer look at why option B might be the correct choice. The best solution is B. Memcache backed by Cloud Data Store for the customer session state data. Lifecycle managed cloud storage for log archives, thumbnails, and VM boot data volumes. Why is option B the best choice? 1. Customer session state with Memcache and Cloud Data Store. Memcache is an in-memory caching system that offers extremely fast read and write operations, making it an excellent choice for session state data that needs to be accessed quickly and persist across application instances. In this case, Cloud Data Store can be used as a more durable backend for Memcache to ensure that session data persists even if the cache is cleared, while Memcache ensures low latency access. Cloud Data Store is a NoSQL database designed to handle scalable, high-velocity workloads, and it can be used to store session state data in a highly available manner. Using Memcache as a caching layer on top of Data Store ensures that session state data is both durable and quickly accessible. 2. Cost-effective storage for log archives, thumbnails, and VM boot data volumes. Lifecycle managed cloud storage is ideal for storing log archives, thumbnails, and VM boot data volumes. The use of lifecycle management allows for automatic transition of data to more cost-effective storage classes like nearline or cold line once the data is no longer actively used, which helps manage costs over time. 3. Scalability and flexibility. Cloud Data Store scales automatically, making it a good fit for managing customer session state data that may grow over time, while cloud storage provides an easily scalable and highly durable solution for large amounts of unstructured data like logs and image thumbnails. Why not the other options? Option reason it's not ideal. A local SSDs are ideal for high performance, but they are volatile, and data may be lost upon VM shutdown or failure. This is not optimal for session state data that needs to persist in the event of VM restarts. Lifecycle managed cloud storage is more suitable for archival and long-term storage needs. C. Memcache backed by Cloud SQL is not a great option for session state data. Cloud SQL is designed for relational database workloads and is not optimized for high-frequency, low-latency session state data storage. D. Memcache backed by persistent disk SSD would still work for session state data, but persistent disk is more intended for block storage and doesn't provide the same in-memory performance or durability that Memcache combined with Cloud Datastore offers. Conclusion. Option B is the best choice because it efficiently addresses the needs of customer session state data with Memcache and Cloud Datastore for durability and low-latency access. It also optimizes storage for log archives, thumbnails, and VM boot data volumes with lifecycle managed cloud storage, ensuring both performance and cost management. This solution strikes the right balance between high performance, scalability, and cost-effectiveness for the given workloads. Question 87. Your web application uses Google Kubernetes Engine to manage several workloads. One workload requires a consistent set of hostnames even after pod scaling and relaunches. Which feature of Kubernetes should you use to accomplish this? A. Stateful sets. B. Role-based access control. C. Container environment variables. D. Persistent volumes. The best approach is A. Stateful sets. Explanation. Stateful sets in Kubernetes are designed to manage stateful applications, ensuring that each pod has a unique and stable hostname, even as the pod is scaled up or down or relaunches. Stateful sets provide a stable identity to pods through stable network identities, persistent storage, and consistent pod names. When a pod is rescheduled or restarted, it retains its hostname, which is crucial for applications that require stable identifiers or need to maintain a specific network identity. Analysis of other options. B. Role-based access control. Role-based access control, RBAC, is used for managing permissions and access to Kubernetes resources. It does not handle pod hostname consistency, so it does not meet the requirement in the question. C. Container environment variables. Environment variables are typically used to store configuration data for containers, but they don't provide a stable hostname across pod restarts or scaling. While they can pass values to containers, they are not designed for managing consistent hostnames. D. Persistent volumes. Persistent volumes, PVs, are used to provide persistent storage for pods, allowing data to persist even when pods are deleted or rescheduled. However, PVs do not address the need for stable hostnames and are unrelated to the specific requirement of hostname consistency. Conclusion. The correct choice is A. Stateful sets, as they ensure that the pod maintains a consistent hostname across scaling and relaunches, making it ideal for workloads that require a stable identity. Question 88. You are using Cloud CDN to deliver static HTTP/S website content hosted on a compute engine instance group. You want to improve the cache hit ratio. What should you do? A. Customize the cache keys to omit the protocol from the key. B. Shorten the expiration time of the cached objects. C. Make sure the HTTP/S header Eurocache region points to the closest region of your users. D. Replicate the static content in a cloud storage bucket. Point Cloud CDN toward a load balancer on that bucket. The best approach is D. Replicate the static content in a cloud storage bucket. Point Cloud CDN toward a load balancer on that bucket. Explanation. Google Cloud CDN is optimized for serving static content stored in cloud storage due to its integration with cloud load balancing. By storing the static content in a cloud storage bucket and pointing Cloud CDN to a load balancer that serves this bucket, you can significantly improve the cache hit ratio. Cloud storage is designed for high availability and scalability, which makes it ideal for hosting static content like images, CSS, and JavaScript files, providing faster content delivery and reducing the load on the compute engine instance group. Analysis of other options. A. Customize the cache keys to omit the protocol from the key. Customizing cache keys can help, but omitting the protocol from the cache key does not address the core issue of improving cache hit ratios. The protocol, HTTP or HTTPS, is typically not a significant factor in cache performance for static content. B. Shorten the expiration time of the cached objects. While shortening the expiration time might increase cache turnover, it can also lead to more frequent cache misses, reducing the effectiveness of caching. This would actually hurt the cache hit ratio over time. C. Make sure the HTTP/S header cache region points to the closest region of your users. That cache region header is not a standard header in Cloud CDN and is not typically used to control cache behavior. Instead, Cloud CDN caches content based on other factors like cache keys, TTL, time to live, and geographical locations of users, but this specific header wouldn't improve the cache hit ratio. Conclusion: the correct choice is D. Replicate the static content in a cloud storage bucket. Point Cloud CDN toward a load balancer on that bucket, as it leverages cloud storage's optimized delivery of static content and integrates seamlessly with Cloud CDN, ensuring high cache hit ratios. Question 89. Your architecture calls for the centralized collection of all admin activity and VM system logs within your project. How should you collect these logs from both VMs and services? A. All admin and VM system logs are automatically collected by Stackdriver. B. Stackdriver automatically collects admin activity logs for most services. The Stackdriver logging agent must be installed on each instance to collect system logs. C. Launch a custom syslogged compute instance and configure your GCP project and VMs to forward all logs to it. D. Install the Stackdriver logging agent on a single compute instance and let it collect all audit and access logs for your environment. The best approach is B. Stackdriver automatically collects admin activity logs for most services. The Stackdriver logging agent must be installed on each instance to collect system logs. Explanation: Google Cloud's Cloud Logging, formerly Stackdriver, can automatically collect administrative activity logs, audit logs, for most GCP services, such as IAM activity and API calls. However, for system logs on virtual machines, VMs, you need to install the Cloud Logging Agent, formerly Stackdriver Logging Agent, on each VM. This agent collects logs such as application logs, system logs, and other VM-specific logs. This setup allows centralized collection of both VM system logs and admin activity logs within your GCP project. Analysis of other options. A. All admin and VM system logs are automatically collected by Stackdriver, while Cloud Logging automatically collects admin activity logs for most services. VM system logs are not automatically collected. You still need to install the Cloud Logging Agent on the VMs to collect system logs, making this answer incorrect. C. Launch a custom syslogged compute instance and configure your GCP project and VMs to forward all logs to it. Setting up a custom syslogged instance is a more manual approach and would not be the most efficient or scalable method in GCP. It requires additional management and configuration, which is unnecessary when Cloud Logging provides a fully managed, integrated solution for collecting logs. D. Install the Stackdriver logging agent on a single compute instance and let it collect all audit and access logs for your environment. Installing the agent on a single compute instance will only collect logs for that instance. To collect logs from all VMs in your project, the agent needs to be installed on each VM individually, not just one. Conclusion: the correct choice is B, as it correctly describes how Cloud Logging works in conjunction with the logging agent to collect both admin activity logs, automatically, and VM system logs, via the agent. Question 90. You have an App Engine application that needs to be updated. You want to test the update with production traffic before replacing the current application version. What should you do? A. Deploy the update using the instance group updater to create a partial rollout, which allows for canary testing. B. Deploy the update as a new version in the App Engine application and split traffic between the new and current versions. C. Deploy the update in a new VPC and use Google's global HTTP load balancing to split traffic between the update and current applications. D. Deploy the update as a new App Engine application and use Google's global HTTP load balancing to split traffic between the new and current applications. The best approach is option B. Deploy the update as a new version in the App Engine application and split traffic between the new and current versions. Explanation of why option B is correct. App Engine provides a built-in mechanism to deploy new versions of your application without replacing the current one. You can create a new version of the application and use traffic splitting to direct a percentage of traffic to the new version for testing purposes. This allows you to perform canary testing and observe how the update performs with real production traffic. If the update functions as expected, you can gradually shift more traffic to the new version or fully migrate. Analysis of other options. Option reason against. A. The instance group updater is used for compute engine managed instance groups, not App Engine. It does not apply here. C. Deploying in a new VPC and using global HTTP load balancing adds unnecessary complexity. App Engine already provides traffic splitting. D. Deploying the update as a completely separate App Engine application increases overhead and is unnecessary since App Engine supports versioning natively. Conclusion. Option B leverages the native capabilities of App Engine for seamless version management and testing with production traffic. It is efficient, straightforward, and adheres to best practices for updating applications.